For those of you still struggling with polar and non-polar molecules, here's just a little practice for you. Make sure you have out a paper, pencil, and a table of electronegativity. Just one molecule here. If you want to see more molecules, please see my video with carbon dioxide and other examples of polar and non-polar molecules. All right, let's get started. All right, so this molecule right here, can you determine the strongest intermolecular force that would occur there? So in order to do this, you're going to have to go through all the steps that we've done to determine that strongest intermolecular force. This is a great time to pause the video to do just that. All right, so hopefully you first look for your total valence electrons, then the central atom, then you looked at your Lewis structure, you finally looked at the shape, you looked at the bond type by looking at the electronegativity difference, and then finally by looking at the molecule and knowing the electronegativity difference between the atoms, you determine the molecule type. All right, so 14 valence electrons, hopefully you came up with that. Hopefully you put carbon in the center. It's listed first and there's fewest of them. Our Lewis structure, again, is I'm putting carbon in the center. For this Lewis structure, nature again always likes symmetry. So as I put carbon in the center, I'm going to draw my three bonds or four bonds around it. 3 for the hydrogens and 1 for the chlorine. And so we're going to get the tetrahedral shaped molecule. As I'm doing this, I've got 2, 4, 6, 8. So I've got 8 valence electrons that I just put in. So I've got 6 more to go. Those 6 are going to go right here on chlorine because hydrogen only needs a duet to have a full outer shell, because its full outer shell is that first energy level. And so as we take a look at what is this molecule going to look like, there it is right here. So let me go ahead. I've got an animated one that I had clipped off the internet. That way you can kind of see that. And then taking a look at the shape of this molecule. Hopefully you would agree that this molecule is tetrahedral shaped. And so if we look at the bond type, let's look at the electronegativity. The electronegativity of carbon and hydrogen compared with carbon and chlorine. And so we can see that for carbon and chlorine, we have an electronegativity difference of oops, let me get my pen, not my eraser. We have an electronegativity difference of 0.61. For carbon and hydrogen, we're looking at 0.35. So we know that that 0.61 is going to, of course, be polar. It's more polar because chlorine is more electronegative. That means that chlorine is pulling on these electrons more. As chlorine has so many electrons, that's what kind of pushes this tetrahedral shaped atom down a little bit. And so as we're taking a look here, we have a polar bond. Whoops. Let me see if I can get that reshaped for you. Here we have a polar bond because that chlorine is pulling on the electrons more, which is going to make this end of our molecule a little bit negative, leaving this end, the hydrogen end, a little bit positive. So we have a polar molecule there because of the shape. We do have both polar bonds and non-polar bonds. But as we're looking at the shape, our intermolecular force is going to be our dipole-dipole attractions. Like I said, because it is a polar molecule. Also, hydrogen is not bonded to FO or N. And so right here, you can see this intermolecular force, which would be dipole-dipole. I hope this helps you as you're working on Unit 3.